'Cause we all just wanna be big rock stars and live in hilltop houses driving 15 cars.
All right, well, welcome back. Our topic tonight is limits analytically. So before we get started, I just want to remind you that if any time you have a question or concern and, we're not at school, feel free to ask questions, start a conversation on Twitter. Our account here is at APCalculusAB. So let's dive right in. Evaluating limits by direct substitution. And I can't stress this enough. We are talking direct substitution. It's that simple, folks. You are taking the number they tell you you're approaching and substituting it in every time. So this says the limit as x approaches 2. So I'm going to replace every x with the number 2. So I've got 2 plus 7 all over 2 squared minus 1. That leaves me with a 9 over 3. So all that's telling me is that my limit, the intended height, is 3. That's simple. Direct substitution. Let's try another one. The limit as x approaches negative 1. So I'm going to replace every x with negative 1. Watch your parentheses, of course. Negative 1 squared plus negative 1 all over negative 1 minus 5. Negative 1 squared is 1 plus a negative 1 gets me a 0 over negative 6, which of course is just 0. 0 divided by any term is 0. So you might be thinking that's great and simple, but what the heck does it mean? Well, it means what we just talked about yesterday. Notice this is a general limit. Okay, there's no left or right side. So if the general limit is 3, that means as I approach 2 from the left and 2 from the right, they are both reaching a height of 3. Okay, they are both reaching a height of 3. That's all we're saying. As I come in from the left and the right, the height is 3. In this case, as I approach negative 1 from both the left and the right, I am reaching an intended height of 0. Okay, it could look like a million different things, but the left side and the right side are both reaching a height of 0. Okay, part 2 is how to put a hole in a function. So let's say we're given the function f of x equals x cubed minus 3x over x, and we had to graph this. Back in our old school days, we would say, we could make a quick table of values and then go ahead and plot the points. So let's start this table of values by substituting 0 into x. So when I substitute 0 into x on top, I get 0 minus 0, which of course is 0. And on the bottom, I would also get 0. Now, this answer is not 0. This is a huge idea for us this year. 0 over 0 is called indeterminate. Okay, get used to saying it, get used to, spelling it, writing it out. 0 over 0 is a huge deal for us. This is called indeterminate. And what that implies is that you're going to have some sort of hole in your graph. You can't have 0 over 0. So think about this function. F of x equals x cubed minus 3x over x. What does your gut, think basic algebra, what does your gut tell you can do to that function? Hopefully you're saying you can factor out on top a variable x. So I've got x squared minus 3 all over x. Now, as I factor that out, what's going to happen to these x's on the one in front and the one on the bottom? Well, certainly from our algebra days, that just tells us those can cancel. Okay? And anytime you cancel a function on the top and bottom, you create a hole. So I know this graph is going to have a hole in it. So to find exactly where that hole is, you take the function you canceled, so I canceled x, and you set it equal to 0. So I know this graph has a hole at x equals 0. So now I can continue to plot this. I'm going to make a graph. I'm going to set up my new function. I would say my new function, now once I cancel, is just x squared minus 3. And I know I have a hole at some point. I know the x value is 0. I can easily get the y value by substituting in f of 0. So I would get 0 minus 3, which is negative 3. So I'm going to start with my hole and plot that point first. I'm going to go 0, negative 3, and literally put a hole in your graph. Not a closed point, but a hole. And now the rest of the graph, I know, again from my algebra days, x squared is a parabola. The minus 3 shifts it down 3. I've got an upward-facing parabola shifted down 3 with a hole at 0. So that's simple. Anytime a piece of your function cancels, okay, that's called indeterminate, and we create this hole. Now let me just be more clear on the whole. Let's say your function was f of x equals the quantity x plus 4 times x plus 2 over x plus 2. All right, let's be real clear. We know we're going to have a whole because this function and this function cancel. Okay, so again, because they cancel, I'm getting a whole. Now, to find where the whole's at, you take the piece that you canceled and you set it equal to 0. Therefore, my whole is at x equals -2. And then to be more precise, where exactly is the whole, I'm going to take and evaluate f of -2. Okay, and now my new cleaned up function is going to say -2 plus 4 all over -2. I'm just using this cleaned up piece. So excuse me, 2 divided by -2 is -1, and that's exactly where the whole in this graph would sit. All right, our next piece, I just again stress in your notebook, we are always trying direct substitution first. If that fails, be creative. You can factor, use the conjugate method, simplify, do what it takes to clean that function up. And how do you know if it fails? Well, again, it fails if you get indeterminate 0 over 0. Okay, but direct substitution has got to come first. So, example 1 here. I am going to substitute in the number 3. So I've got 3 squared is 9, 9 minus 9 is 0 over 0. Do you have to show that step? Yes, that's got to be on paper. Show you get indeterminate form first. So again, indeterminate. Now once you've got indeterminate form, that's how you know it failed, and you're going to get creative. So just think basic algebra, folks. What does your gut tell you to do on top? Hopefully you're saying factor. X plus 3, x minus 3, all over x minus 3. Okay, we've got a nice whole. Where is your whole sitting? Hopefully at x equals 3. And now I'm going to evaluate my limit. So my new equation is really the limit as x approaches 3. And I'm only substituting it into what's left, x plus 3. So I would say my limit is 6. Okay, and if I were to graph this, I do have a whole, and that whole is at 3. All right, let's try the next one. You've got to do direct substitution first. Sometimes it works and you get tricked. All right, so -2 squared is 4. 3 times -2 is -6 plus 2 all over 0. So 4 plus 2 is 6. So I do get 0 over 0. I get indeterminate. So now try something else. I'm going to try factoring again. I've got perfect squares on the bottom, x plus 2 and x minus 2. On top, I'm thinking x plus 2 and x plus 1. Hopefully you're on the same page. So again, I can cancel the x plus 2's. They are gone. That creates that whole. Okay, and the whole is at x equals, hopefully you can do that in your head, -2. And now try direct substitution. You're always going back to direct substitution. So I'm substituting in -2. -2 plus 1 is -1. -2 minus 2 is -4 for a nice 1/4. All right, well, why don't you take number 3, pause it, try it on your own, see if we get the same thing. Okay? So hopefully you followed my work. I got a solution of -1/2, and I just again want to stress my whole is at x equals 0. That's where they canceled. Now again, that's not the answer to the question. We're just, keeping that in our mind for further knowledge. All right, you got one last one. Again, pause it, see what you get, and hopefully we're good to move on. So I've got mine factored. I just want you to be real cautious. Whoops, when you cancel these, remember they are different by a negative. They are backwards, so I'm canceling to negative, and I still have the quantity x plus 2 over 3. Still substituting in that 7, so I get a -9/3, or of course just a plain old -3. All right, well, if you're feeling good there, we'll keep chugging. All right, in this case, again, you've got to try direct substitution. It's not an option. You have to try it first. So I've got, if I plug in a 4, I get 0 over 0. Okay, so again, that word is indeterminate, which doesn't tell me I'm done. That tells me try something else. So in this case, I could factor the top, but I can't factor the bottom, so that's not going to cancel at all. So my big key is when I see a radical, that's going to imply to rationalize. And we did a ton, We've done a ton of rationalizing, whether it was in Algebra 2 or pre-calc. We do a lot of it in Algebra 2. Now you can either rationalize the numerator or denominator. It's wherever the radical is. So let me rewrite this. And I guess hopefully I'm not going too fast for you. When I say rationalize, let's make a note. We are multiplying by the conjugate. Okay, multiply by the conjugate. So I simply say to myself, I know I'm indeterminate. I got 0 over 0. Where is the radical sitting? In this case, I see the radical on the bottom. So I'm going to rationalize by multiplying by the conjugate. Simple. So the conjugate of 2 minus radical x is 2 plus radical x. Whatever you do to the top, you do to the bottom, or vice versa. Now, I can't stress enough, all right? You're only going to multiply the conjugates, not the other part. So every time, until you plug in that number 4, you are going to rewrite the limit as x approaches 4. You will lose a point every time if you don't have that. All right, I'm not going to multiply the two tops together. I'm just going to rewrite them. I've got 3x minus 12 times 2 plus radical x. All right, it makes my life easier. And in fact, if I multiplied them, I'd have to factor them afterwards. So don't multiply. Now, you're always going to multiply the conjugates because that's extremely simple math. The 2 times 2, if I FOIL that out, of course, gets me 4. The middle terms and conjugates always cancel. You'll notice I'll get 2 radical x, and then I'll get negative 2 radical x, so they'll cancel. And then I've got a negative times a positive, which is a negative. Any radical times itself is just the junk under there. So I get 4 minus x. Now, again, don't multiply the top. I'm going to keep going. What could you do? You can factor that one term. Okay, the idea is if you did it right, something should cancel. So if I pull out that 3, I get my x minus 4 and my 2 plus radical x. And I still have my 4 minus x on the bottom. Now again, I know I did it right because these terms are canceling. Remember, they do cancel to a negative. So I really have the limit as x approaches 4 of negative 3, 2 plus radical x, all over 1, which obviously I don't need. Now, don't forget your direct substitution. Plug in that 4. So I've got negative 3 times 2 plus the square root of 4 is 2, which gets me a negative 12. So if you thought that was intimidating, we're going to practice another one. The idea is multiply by the conjugate. Literally multiply the conjugate terms, but not the other terms. It will make your life easier. Let's try another similar one. All right, if you're feeling in the groove, feel free to pause it. I'll talk through it again. Like I said, if you think you've got it, pause it, and then you can just kind of skip to my answer and see if you got it right. So again, I'm checking for indeterminate first. You have to plug in the 0. If I plug in 0, I do get 0 over 0. Okay, so I'm indeterminate, which means I'm not done. I just got to get creative. I see a radical, so I'm going conjugate method. Now notice my radical's on top this time, so I am going to take the conjugate of the numerator. Okay, so I'm going to multiply by radical x plus 1 plus 1, changing that sign of the middle term, all over radical x plus 1 plus 1. Okay, I'm multiplying by the conjugate of wherever the radical is. So as I continue, make sure you keep that limit in front. You will lose that point if it's not there. And the only one I'm going to multiply is the ones that are actual conjugates. So this time I'm multiplying the tops together because they are conjugates and the middle terms will cancel. So any radical times itself is just whatever it is. So that's x plus 1. Middle terms cancel. And now I'll do the last terms. It's going to be a negative times a positive, and a negative 1. On the bottom, don't touch it. Just write each term down. It will make your life a lot easier. Okay, now if we did it right, something should cancel. I'm going to go one more step and clean up the top. Do you notice you have a plus 1 and a minus 1? I'm going to call that just x over x radical x plus 1 plus 1. Now, hopefully you're jumping for joy. We did it. Those x's are going to cancel. We know we did it right. Of course, that leaves us with a 1 on top. And now don't forget to plug in your 0. So I'm going to get a 1 over, this is going to be the square root of 1, which of course is 1, plus 1 is 2. And there you have it. Now, conjugates may not be your favorite, but they're definitely not too hard. Just take your time and keep your algebra nice and neat. I've got another type to show you. All right, like always, we're starting with direct substitution. If I plug all my zeros in for the x's, I get 1/3 minus 1/3, which is 0 over 0 indeterminate form. Doesn't mean I'm done, it means get creative. So again, there's no radical, so there's no conjugate. Clearly you're not going to factor. What does this problem remind you of? And again, just think back to your algebra days. It all comes back to algebra. I see a complex fraction. Hopefully that's what your gut was telling you. And all I'm going to do is treat it like 1. I'm going to rewrite this term as x over 1. All right, so back from, again, Algebra 2, pre-calc, complex fraction days, the rule is you just multiply by the common denominator. So let's just take a moment and ask ourselves, what is the common denominator? If you look at every fraction and its denominator, okay, I see this denominator is 3 plus x, so that's 1. This denominator is 3, and this one's a 1. Clearly you don't need the 1. So I'm going to say my common denominator is a quantity 3 plus x and the constant 3. So I am going to put that next to every single term and always in the numerator. So I'm going to say 3 plus x and 3. Takes a few seconds. Nobody said it was going to be quick. And notice it's in the numerator. Goes next to every term. All right. Now the idea is you should be able to kill the fraction and make one fraction. So I'm still keeping this limit until I plug the 0 in. This 3 plus x and this 3 plus x are gone. So 3 times 1 is 3. This 3 and this 3 are gone, so I have a minus sign. And notice I'll have the quantity 3 plus x. Okay. Biggest mistake is people not putting in the parentheses there. Watch those parentheses around that quantity. Here nothing's going to cancel, so I'm just going to write them all down. I am not going to waste my time multiplying. Just write them down. All right, now, don't cancel until you clean up. I've got a 3 minus x all over the x, 3 plus x, and 3. Okay, notice I'm not canceling anything because of this minus sign. I'm cleaning up. 3 minus 3 is gone, so I have this negative x over this junk, so these x's can cancel. And I have the limit as x approaches 0 of negative 1 over 3 plus x and 3. Now I can substitute my 0 in, and I get negative 1 all over 9. Okay, so our biggest mistakes are going to be in just our basic algebra. Here's a big catch for people. Make sure you put minus that quantity. Remember, you can't cancel these because of this minus sign. All right, so it's lots of little, it's not calculus that's hard, it's just the little algebra techniques that we get sloppy on. All right, I promise one last one and we'll be good for the night. Okay, in this last case, I just want to slow down and I want to make one fraction before I test my limit. Okay, so again, it's all about that common denominator, a little more algebra review. I'm going to factor these and clean them up just so it's easier to state the common denominator. So I'm going to say this is 3 over 3 times t minus 2 and 4 over t minus 2 t plus 2. Okay, so now, when I ask myself, what is the common denominator? I look at the denominators, and I need one of everybody. So I need just a plain old 3. I need the t minus 2's, and I need the t plus 2. Okay, so I'm going to rewrite each fraction with that common denominator. So I have the limit as x approaches 2. I'm going to say this first fraction is going to be a 3t minus 2t plus 2. And I'm going to multiply the top needs the t plus 2. Okay, then I have a minus sign. This denominator is my common denominator. T minus 2 and t plus 2. This had the t minus 2 and t plus 2, so it just needs the 3. So as I clean this up, whoops, that t looks goofy there. I'm going to get the limit as x approaches 2. I'm just going to clean this one up right here. This is 3t plus 6, if I distribute that. And this is just 12. So I'm going to say I get 3t plus 6 minus 12 all over that common denominator, which of course is 3t minus 6. And let's see, I can factor out the 3 here, and I get t minus 2, which tells me those cancel. So I'm left with the limit as x approaches 2. On top I have the, oops, I can cancel those 3's as well, which is awesome. So basically I have 1 over t plus 2. Now I can substitute in the 2 for t, and I get 1 over 4. All right, well, you have it. You have bits and pieces of all these different limits. Remember, you're always trying direct substitution. If it works, you're done. If it doesn't, you have indeterminate, and you're either factoring, conjugate, simplifying, or adding fractions. So if you have any questions, again, you can tweet at us. You can come see me in the morning, but I'll be around, and good luck. We'll see you tomorrow.